welcome to, this is Unit 5, Lesson 2, Compound Interest Continued. We started talking about compound interest on the last unit, and then it meant you took the interest, added it to the principal, and compounded the interest and the principal together to earn more interest. So the formula we looked at then, or the formula for compound interest, is A equals P bracket 1 plus I, the exponent N, where A is the amount of the investment in the future, P is the principal, I is the interest rate per compounding period, and N is the number of compounding periods. So the number of compounding periods in a year depends on the type of compounding. The table below outlines how to change I and N based on the type of compounding. And compounding just refers to how often they're calculating interest. So when you have an annual type of compounding, that means interest is calculated one time per year. So there is no adjustment to I. I just stays the same. And there's no adjustment to N. N just stays the same. If you have a semi-annual type of compounding, that means that you are compounding or calculating interest 2 times each year. So you have to take the whole interest over the year and you divide it by 2. Because you're calculating it twice in the year, so it gets split up 2 times. If you're calculating interest twice each year, then you have to take your time frame and multiply it by 2 to find out what your adjustment to N is. And the same happens for quarterly. Quarterly is 4 times a year, so your adjustment to I would be the interest rate divided by 4. Or your years, I should change that actually to our years. So N would be our years times 4. 4 times each year would give you the number of times you compound in total. And monthly is your yearly rate divided by 12. And N would be your years times 12, because there's 12 months in each year. Daily would be your interest divided by 365, and N would be your number of years times 365 days in each year. What that looks like when we go to use the formula, determine the amount of interest earned or paid using the formula I. We talked about this before. The accumulated amount minus the principal tells you your interest. So determine the amount and the interest for each of the following. So the amount comes from the principal times 1 plus I to the end, and the interest comes from taking the amount you accumulate minus the principal. So there's our 2 formulas. And I mentioned earlier that you're going to want to make a list. We have to figure out what our A is. We know our P is $2,500. We know our time is 10 years compounded annually, so it's still just 10. N is the number of years, 10. And our I, because it's compounded annually, is 4% each year. So our I just stays the same, 0.04 once each year. So we have 2,500 times 1 plus 0.04 to the 10. Then we get out our calculator and we calculate our answer. So 2,500 times 1.04 to the exponent 10 gives us a grand total of $3,700.61. That's the amount that's accumulated. To get just the interest, we take the amount that accumulated with the interest and we subtract the principal we started with, which is $2,500. Subtract the $2,500, we get an interest in the amount of $1,200.61 in interest. Let's take a look at another one. This time, we're going to compound semi-annually. That means 2 times per year. So nothing is going to change about our accumulated amount. We're going to figure that out. Our principal this time is $2,550. Our interest rate, however, and our N has to be adjusted for compounding 2 times a year. So if I have 7% compounded twice a year, that means they calculate the interest twice per year. So you have to take your interest rate and split it up between the 2 times that you're calculating in each year. And sometimes that works out nicely, 0.072, like this time, which is 0.036. And sometimes it doesn't work out nicely and you have to leave the fraction for your interest rate. Our N, if we're calculating an interest twice each year for 8 years, that means we'd have 8 times 2. We're going to calculate interest 16 times for 8 years, twice each year. So my A is 2550 times 1 plus 0.036 to the exponent 16. So 2550 times 1.036 to the exponent 16 gives me an accumulated amount of $4,490.52. And to get our interest, we take our accumulated amount. Oops, that'll be 52, not 50. And take away the principal. And we'll see that our interest was almost $2,000, $1,940.52. So that's compounded semi-annually, twice a year. If we look at one that compounds quarterly, quarterly means 4 times each year. So my principal is $5,000. My interest rate, 9%, 0.09, has to be divided by 4 over the year, which is 0.0225. And my time, 4 years, 4 times each year, means there'll be 16 compounding periods. So I've got my principal, 5,000 times 1 plus 0.225 to the exponent 16. So 5,000 times 1.0225 exponent 16, $7,138.11. And if I want to get my interest, I take the accumulated amount and subtract the principal, whoops, which was $5,000 to start with, which means I've got just over $2,000 in interest. And if we look at another example with a different compounding period, compounded monthly means 12 times each year. So we've got to remember to adjust our interest and our N and our time frame. Principal, $1,650. Our interest, 0.06 divided by 12, 0.005, and N is 12 years, and 12 times each year means the interest is calculated 144 times in 12 years. So my amount is 1,650 times 1.005 to the exponent 144. 650 times 1.005 exponent 144. So we have $3,383.74 accumulated. Again, the interest is the accumulated amount. Why I put that there? Let's try that again. $3,383.74, the accumulated amount, taking away the principal, $1,650, which is going to give us interest of $1,733.74. One more quick example, when it's compounded daily, means 365 times a year. My principal is $750. My interest rate is 0.18 divided by 365. And if I try to do that on my calculator, I get a crazy long decimal that doesn't end. This is one that you need to leave your interest rate as a fraction. And our n would be 30 days. So we have 30 out of 365. Excuse me. 30 out of 365 days, because you don't have a full year. So we have 750 times 1 plus 0.18 divided by 365. And then we have part of a year. So 30 over 365 as our exponent. If you had more than a year, then you do 365 times however many years. So now it becomes how good you are at entering in your calculator. 0.18. That to the exponent. You're going to want to put a bracket around your exponent. And I've got $750.03. Now I'm going to double check that. Divided by 65 plus 1 to the exponent bracket 30. Oh, wait a minute. Wait a minute. We did this wrong. I did this wrong. Our n isn't 30 divided by 365. Our n is actually 30. And that is only because it's compounded daily. So if I invest my money for 30 days, it's going to compound interest each day, which is 30. All right, now I got my head screwed on right. We'll try that again. Maybe we'll get an answer that makes a little more sense. Exponent 30, go times 50. That makes a little more sense. $761.18. So you've really got, as you see, to watch those compounding periods. Because it's compounded daily and invested for 30 days, your n is 30.